to our lesson for today is to find the volume. Okay, guys, today we are going to learn about area and volume of different geometric figures. So we are in the first part. We are going to see area of triangle, area of some quadrilateral. So you have rectangle, square, trapezoids, stuff like that, and also find the area of a circle. And in the second part, we are going to talk about volume. So volume of different geometric figures, volume of rectangular figures, volume of a cone or a pyramid or a sphere or cylinder. So we are going to look at different formulas. So the lesson is relatively simple. All we are going to do is identify the different formulas we are going to use for area, formulate those area formulas, and just substitute and use those formulas. For volume, we do the same thing. We figure out the different formulas we use, and we apply those formulas. Okay. Okay, I'll start my lesson here from area. That means the first topic is area. Now, first area of rectangular figures. If you have a rectangle, the area would be length times width. I hope almost all of you know this, because this is middle school math. Area is, this is just to review, area of a rectangle is length times width. The area of a rectangle with length L and width W is given by the formula area equals L times W. And the area of the square would be S squared, where S is one of the sides of the square. So area deal with two-dimensional figure, length and width, two-dimensional. So how much space is covered in two dimensions? Okay, so we have area area of a rectangle and area of a square is given by that. Now next, we go to area of triangle. Sorry, area of parallelogram. So parallelogram has two sides which are parallel. These opposite sides are parallel. That's why it's called parallelogram. Now, for parallelogram, this is what will happen. So if you move this rectangle, sorry, the triangle, let me redraw the. So let me redraw that. I'm going to move this orange triangle to the left-hand side. So we move this orange triangle to the left-hand side. So let me draw it on the same thing. Okay? So if you move that, you will get. So this will be here. Will come here. So we have B times H. So the area will be B times H, area of rectangle. So if you ignore this and if you consider the new, let me use different highlighter. So let's consider the green one. If you consider the green here, the area becomes B times H. So this area is B times H. So the area of a parallelogram is the base times height. So we have one example here. You can see on the right hand side. Says find the area of a parallelogram whose altitude is 20 inches and the base is 18. So you have this parallelogram here. So this is altitude is here h 20 and this is 18. Sorry about the dimension. So the base is up. So this is also 18. So area is b times h. So what would be the area? Type on the chart. I know these things are very simple. Just to show you the different formulas. Basically, the objective of this lesson is to refresh your memory about different geometric figures. So area would be how much? Type on the chat. Yeah, inch square. Don't forget. So this is inch times inch. So this is equal to 18 inch times 20 inches, which is 360 inches square. Okay, so parallelogram, if you know the altitude and if you know the base, just multiply the two, it will give you the area. Simple as that. Okay. Now let's see the next geometric figure. Area of a triangle. Okay. Area of a triangle. Okay. So area of a triangle is half b times h. B times h. I will show you why it is half b times h. So we have, let's say we extend this. Let me use a little different color. Okay, red is better. So let's extend this. So these two triangles are the same. You see, the two triangles are the same. So we have half of the two triangles. And here, if you extend here, again, the two triangles are the same. So the area of the bigger rectangle, the rectangle is b times h, and the triangle is half of it. That's basically why we use half h times h. If you see here, these two areas are the same. So I'll use like color coding. So the green ones are the same. These two areas are the same. So we take half of that for the triangle. And also these two triangles are the same. This triangle and this triangle. So we took half of that. And the area of the rectangle, the bigger one is b times h. And it is half of. So this is b times h. Because this is h. So the area of the bigger one is b times h. And we took half of it. Okay, so this is the formula I want you to remember. Area of a triangle, if you manage to find the altitude h, the area will be half of b times h. Okay. Now let's do some examples. Find the area of a triangle whose altitude is 22 centimeters. Oh, sorry, the altitude is bigger, but don't worry about the. So let's say this is 9 inches. So find the area. I know this is simple. Just start, multiply, and type your answer on the chat. Excellent, Hugo. Exactly. So all you have to do is just half times 9 times 22. So which is 198 divided by 2, which equals 99 inch squared. Square inch or inch squared. Excellent. So that's how you find area of. Yes, okay. Yeah, divide by 2. Yeah, don't forget to divide by 2. It's okay. So this is how you find area of a triangle. Next geometric figure is a triangle again. But what if we don't know the altitude, but we know all the three sides? So there is a formula called Heron's formula. So he developed a formula where he has a parameter which is called Heron's constant S. So this is the constant S here. It is a semi-perimeter, half a perimeter. So S here is half a perimeter. You add all the sides and divide it by 2. Now this parameter is used to find the area of a triangle. You know all the three sides. What it do is the area equals the square root of S times S minus A times S minus B times S minus C. You take this parameter, you multiply by S minus one of the sides, again S minus the other side times S minus the third side. And that gives you the area of the triangle. So now I want to try this. Find the area of the triangle here, which is given A equals 15. Let's say A is 15, B is 8, C is 9. Okay, find the area. Use the formula. First find S, which is A plus B plus C divided by 2. Then after that, you take square root of S times S minus A, S minus B, S minus C. Okay. So this is the area. Well, let's find S together. So first you have to find S. In this case, S is half of the perimeter. So S equals A plus B plus C, which is 15 plus 9 plus 8 divided by 2. Multiply and divide by 2. I don't see your answers. So it is 16. Excellent. So S is 16. Now once you find S, you take square root of A of B, square root of S, which is 16, times 16 minus A, which is 16 minus 15. A is 15. Then 16 minus B, B is 8. And 16 minus C, which is 9. So remember at the end you'll get, it is 8. We don't have units, so don't worry about it. So whatever unit square, so just start unit square. Okay, now let's evaluate this. So this equals the square root of 16 times 16 minus 1, 15 is 1. 16 minus 8 is 8. 16 minus 9 is 7. Go ahead and multiply. 16 times 8 times 7. Square root of 100, sorry, 896. So what is the area now? It is the square root. Yeah, you are right, Hugo. So take square root of that. Not a square root. So the square root of that is 29.9. Unit square. So we don't have units, so unit square. Whatever unit it is, it should be squared. Okay. Okay. Yep. So that's how you find area of a triangle if you know all the three sides. If you have right triangle, I don't know if I have right triangle. If you have right triangle like this, so this would be the base, this would be edge. So area is half h times b. Okay. So it's the same thing, but the altitude is one of the legs. The altitude would be one of the legs. You take square root of that. The square root of 896 is 29.9. The square root. See the square root? Anyone who has got 29? Is there anyone who got 29.9? Yeah, yeah. So you take square root of 896. That's how we got 29.9. I know this is just plugging numbers, but you have to practice. Okay, so you have to practice. Otherwise, it is simpler. If you know the formula, I'm just introducing the formula. All you have to do is just practice and work on the assignments so that you will get them in your mind. So if you remember the formulas, it's just evaluating expressions. That would be something I know you can do. So let's go to the next geometric figure. So we're done with triangles here. Now we have something called trapezoid. So trapezoids have two parallel bases, A and B. So the top and the bottom here, A is the bottom here, B is the top. Now, I want you to consider the two triangles here. The one with yellow color, the area is half of A times H. A is the base, H is the height. And the second one is also half of B times H. The height is here, the same height, B times H. So when you combine the two, when you add the two, the area becomes half of H times A plus. So area equals half H times A plus. So area of the yellow triangle is half of A times H. So just copy that. Plus area of the red, it says red, but it looks like orange for me. But okay. So area of the orange one is half B times H. So when you add the two, you'll get half of H times A plus B. So when you combine the two, half is common, H is common, you take out half and H, then you add A and B. Okay, that's the formula. If you know A, if you know B, and if you know H, you can easily figure out the area of a trapezoid. Okay, let's do some examples so that will be more clear. Oh, sorry guys, this is 7. Can you guys see the numbers? Let me write it. This is 7. This is 7 meters. This is 13 meters. 9 meters. So A is 7, B is 13, and H is 9. And we said the area is half of H times A plus B. So just add the top and the bottom. Okay, now this equals half of 9 meter times the top is 7 and the bottom is 13. So half of 9 times this would be 20. Half of 20 is 10. 10 times 9 would be. How much did you guys get? Just type your answer on the chat. Yeah, 90 meters square. So half of 20 is 10. 10 times 9 would be 9. That's the area. Any question? So trapezoids are very simple. You know, the dimensions is really straightforward. You have to substitute the numbers. That's all you have to do. Substitute and evaluate. Okay. Okay, now let's see another geometric figure we are going to consider. Here it is circle. The area of the circle is pi r squared. Area of the circle is pi r squared, where pi is usually 3.14. Use 3.14 if you are given, okay? If you are not given, for area especially, usually it will be given. If it is given, use pi. If it is not given, you guys don't use it. Just put in terms of pi, then so usually in books it will be given. So pi equals 3.14. It says pi equals 3.14, just straightforward. Now, for example, if I have a circle with radius, let's say 4, so it will be area equals pi times r squared, 4 squared, 65. So I'll just say 65. Okay, like that. So if the pi is not given, sometimes I think on the assignments you are going to do pi will be given 3.14. So all you have to do is multiply 65 by pi, so you have that number. So approximation 16 times by pi, 16 times 3.14. If it is given, you will get 50.24. And you'll be given around to the nearest tens or hundreds. If it's the nearest tens, that's it. 50.2. Okay. So pay attention to what is given. If pi is given 3.14, use it. If it's not given, just 65 will be the answer. Now, let's see this example. It says find the area of a circle with a circumference of 5 feet squared. So just 5 feet. The circumference is given. So let me give you the formula for circumference. C is 2 pi r. Now, what is given is the circumference. For area, we need radius, not circumference. So we have to find the radius to find the area. So what you have to do is use the formula for circumference, which is, in this case, the circumference is 5. So I will use 5 equals 2 pi r. So I can find r. If you divide both sides by 2 pi, that's r. So this will be cancelled out. That means r is 5 over 2 pi. Now, once you know r, you can use it to find the area. So area is pi r squared. That means 5 times r is 5 over 5 squared. So square everything in the radius. So 5 squared is 25. 2 squared is 4. 5 squared is 5 squared. So 1 pi would be cancelled out from the square. So I have 25 over 4 pi. So that's the area. So if you have pi plus 3.14, you just substitute 3.14 and you'll get the answer. You have to round it. You guys get it? How do I find r? And then I use r to find the area. So in short, for example, in short, I can divide the general formula. So for example, C is 2 pi r. If I know C, I have to divide by 2 pi. That means r is C over 2 pi. So if I substitute into area equals pi r squared. So area would be pi times C over 2 pi the whole squared. So when you square, you have pi times C squared over 4 pi squared. So again, this cancels out. At the end, you'll get C squared over 4 pi. Now, so we can see a general trend. If you are given a circumference, the area will be the circumference squared divided by 4 pi. Circumference squared divided by 4 pi. So if I have another example, example 2, find the area if C is 16. If I say C is 4, I mean, let's say P. This is P squared, sorry. So now if I say find the area if C is 4 feet, how much do you think the area of? You can use this, the last one here. Use this. You can move around formulas. That's why we studied literal equations. If you guys remember from previous unit, studied literal equation. That's one of the application of literal equation. Anyone with the answer? What would be the area if the circumference is 4 feet? Right, in terms of pi. Let's try it. You guys understood the problem? Oh, okay. So what is given is the circumference. So we have given the circumference. So let me see. C equals. So let me write the formula first. So C equals 2 pi r. Area equals pi r squared. Now, if you are given the circumference, you can use the first formula to find the radius because we need the radius in the second formula for area. So it says the circumference is 5. That means 5, because the circumference is 5, 5 equals 2 pi r. Remember, pi r, 2 pi is a number, the coefficient of r. So to solve for r, I have to divide by 2 pi. Okay? Both sides. Now r is 5 over, so r is 5 over 2 pi. So I'll use this and substitute into area formula. The area is pi times r, which is 5 over 2 pi squared. So when you square each of them, each number. So you have 5 squared, 2 squared, 5 squared. You square each one. So 5 squared is 25. 2 squared is 4. 5 squared is 5 squared. So 1 pi will be cancelled out because you have 2 pi's here, 5 squared. So finally you have 25 over 4 pi. Now if you see this, technically this is the circumference squared because the circumference is 5. It's the circumference squared, which is 25 divided by 4 pi. If I say if c equals 4, what is a? All you have to do is you square this, c squared over 4 pi, which is 4 squared over 4 pi. Yeah, 16 over 4 pi. So by 4, this is 4 over 5. That's it. You square the circumference and divide it by 4 pi. Okay. Okay. Now let's move to the next topic. So we are going to move to area. Sorry, volume. Volume. So that's the next topic. So we are going to look at general understanding of concept of volume. What is volume? So we are going to define it. Then find the volume of rectangular solids, tubes, and rectangular shapes, and find the volume of a cylindrical shape. Find the volume of pyramids, cones, and sphere. So we are going to consider at least 5 geometric figures, 5 different geometric figures. So volume considers 3 dimensions. It's 3 dimensions, not 2 dimensions. So we have 2 dimensions here. We will add the 3rd dimension. So we are going to look at things in 3 dimensions. Okay. For example, if you have a so it is the space occupied by a geometric figure in 3 dimensions, not only 2 dimensions, in 3 dimensions. Okay, that's what we are going to look at. Okay, now introduction. We have previously looked at perimeters and area as measure of plane geometric figures. So plane means it's 2 dimensional. When we talk about area, it is 2 dimensional. When we talk about perimeter, it's even 1 dimension. Just the distance around a circle or a rectangle or a triangle. That's the perimeter. And another measure is volume. Volume is 3 dimensional. So considers the measure of amount of space occupied by a solid figure. So it will find the measure of the amount of space occupied by a solid object. Okay. Now let's see the first geometric figure. So the first kind of geometric figures we are going to look at will be rectangular. Now, if you see here, we have rectangular solid, and special kind of rectangular solid we are going to consider is cube. We have here rectangular. So the volume of rectangular solid is the product of the length, width, and the height. Length, width, and height. So you just multiply the three dimensions, you'll get the volume. So in terms of physical, let's say this is 1 unit. You see this cube, you have 1 unit of that. Let's say this is 1 meter cube or 1 unit feet cube, feet square, feet cube, I mean, or meter cube or centimeter cube. It can fit, for example, a 3 by 3 by 2 will fit 18 of this small cube. So to be 18 cube of whatever unit you have, if it is meter, you will have 18 meter cubes. So it will. So you can see physically, you can put 18 of them inside. So this is 1 here. So you can put 18 of them. See each unit. That's basically what volume is. So if you have 1 cubic unit, and if you know the dimension here, the length is 3, the width is 3, the height is 3. So we have 3 times 2, which is 18. So we'll put 18 cubes. 18 cubes inside this rectangular geometric figure. Okay. Now, let's see the next geometric figure. Before that, we can do one example. Let's do one example here. Now, find the volume of the rectangular solid. I want you to find the volume and type your answer on the chat once you finish. So the dimensions are: the length is 20, the width is 8, the height is 16. Straightforward. I know you guys, this is easy for you, just to give you like a review and just to remind you there are different geometric figures we consider. Excellent, Chico. So the unit is now centimeter cube. So all you have to do is volume equals length, width, and height, which is 20 times 8 times 16 which is 2,560 centimeter cube. So the unit is now cube. So it is 3-dimensional. Okay? So it is 3-dimensional. Excellent. I know almost. I know all of you got this one, right? So some of you don't try. This is okay. Now let's go to the next one. The next geometric figure is cylinders. So for cylinder, if you consider like the base, here you can see at the top, we take 1 unit here, the volume would be the area here at the top times that height. So the area here at the top, which is pi r squared. So volume is basically area times the 3rd dimension, h. Area times the 3rd dimension, h. So you take that area and you multiply it by the overall height, you will get the volume. So in this case, area is pi r squared. Area of a square is pi r squared. So it is pi r squared times h. So the volume is here. I'm going to highlight it for you guys. So the volume is pi r squared times h. So the pi r squared is the area of the base or the top. The same thing for cylinder. Okay, now let's do the example. So the example says find the volume of a cylinder with diameter of 11 meter. So the diameter is given. Here we have this. So we have 11 meter diameter. Sorry about that. and this is 14. Now you can see here, pi is given 3.14, so you have to use 3.14. If it's multiply and find the volume of B equals pi r squared times h. So the r is here 5.5. Just divide 11 by 2, so it is 5.5 meters. You guys type your answers. Just plug in the numbers and multiply. That's all you have to do. If you know the formula, it's just evaluation. It's a matter of evaluation. Excellent. So it says to the nearest tens, that means the first digit. Very good. So you have 3.14 times 5.5 meters squared times the height, which is 14. So 3.14 times 5.5 squared times 14, which is 1329.8. It's just evaluation, basically. Okay, now let's go to the next geometric figure. So the next geometric figure is the pyramid. So the pyramid has a base which is can be squared or can be rectangle. Usually it is square. Unless it is a square, you can't fit the top. So the base is square. You see here, let me highlight it, the base. You can see so this here is the P. Okay, that is what P is, the base. So the base times the height will give you volume of the rectangular figure. If you extend this, you'll get a rectangular figure here. Something like that. Sorry. So there is a rectangular figure. So it is 1/3 of that rectangular figure. 1/3 of that rectangular. So the volume of a pyramid is the base, which is the base area B, times the height divided by 3, or it's just 1/3 of that. Okay, 1/3 of just this is what you have to remember. It's just the formula. 1/3 of uh, the rectangular figure. Okay, now we have this question. So, as you guys know from on the strip, we have the Luxor Hotel. So the Luxor is said to be based on the same shape as the Great Pyramid in Giza, Egypt. Find the volume of the Luxor if it has a square base of 60 feet and height of 350 feet. It is as large as the Great Pyramid of Giza, which has a volume of this much. So we are going to compare it to the pyramid in Giza, the one, the original pyramid in Egypt. So this is, I don't know exactly. Let's say this is the pyramid, okay, or the. So you have 600 by 600. and the height here is 300 feet. So find the volume here and compare it to the original pyramid. That's basically what we are doing. If you have calculator, multiply that. The area of the base B is 600 by 600 square feet. 600 by 600, which is 36 zeros and 0, 0, 0. We have 4 zeros. Right. Now the volume of the pyramid is 1/3 times B times H. 1/3 of 360,000 squared times 150. How much you guys get? 42 million cubic feet. So if you multiply all this, you get 42 million feet. So even if they base the design from the original pyramid in Giza, it is almost half, even less than half of the pyramid in Giza. So the pyramid in Giza is 91,227,778. The pyramid here in Luxor, Vegas, it is 42 million square feet. So it is even less than half of the original pyramid. They can't build that big pyramid around airport. Okay, so it is less than the pyramid in Giza, of Giza. Almost half, less than by half. Okay. Okay, now let's go to the next geometric figure. Next we'll see cones and sphere. Cones and sphere. Cone is 1/3 of a cylinder. Cone is 1/3 of a cylinder. We know how the area of a cylinder is pi r squared times h. So we know the area of the the volume of a cylinder is pi r squared times h, and cone is 1/3 of that. So you have 1/3 pi r squared times h. So write down the formulas and the geometric figures. And also the area of a sphere, spheres are circular objects, is 4/3 pi r cubed. 4/3 pi r cubed. For example, different balls, basketball, volleyball, different balls have different radius, and we can use this formula to find the volume. So at this level, we're not worried about how to get these formulas. You can prove them. You can find the area. You can derive them. But for this level, we don't need to derive the formulas for volume or area. It's just understanding the different shape of geometric figures and what kind of formulas we use to find the area. That's the objective. Okay. Now let's see some questions on this. So the first example says find the volume of a cone with radius of 3 meters and height of 9 meters. use pi equals 3.14 round to the nearest 7. Okay? So there is a cone here. So the radius is 3 meters. So the radius is 3 meters and the height here is 9 meters. So area equals, so volume equals 1/3 pi r squared times h. So this will be 1/3 times 3.14 times pi times r squared, or r is 3 meters squared, times our height is 9. So just multiply them. So 3 squared is also 9. 9 times 9 is 81. 81 times 3, around 81 times 3. So 3.14 divided by 3 times 9 times 9, which gives you 84.78. So which is 84.8 meters cubed. So check your answers. Okay, you have to check your answer. If you get something different, please let me know. Is it visible? Sorry, I used yellow. I don't know why I choose yellow. Sorry. Maybe it helps. Okay. So the next question is, what is the difference in volume between basketball with diameter of 9.5? So there is a basketball. The diameter is 9, or the diameter 9.51, and there is a base volleyball, and the diameter is 8.39. Okay, so the volume here is volume 1. Volume of the basketball is 4/3 pi r cubed. Sorry. So the volume here is 4/3 times pi 3.14 times r is 9.51 divided by. So divide that 9.51 divided by 2 is 4.77755. So it is 4/3 3.14 times 4.755 squared. So I just multiply this. I know it is just multiplying numbers and evaluating expressions. So it gave me 94.7. The unit is inches. So you do the same thing for the volleyball. So the volleyball, so the ball, the radius would be half of this, 8.39 divided by 2, which is 4.195. So the volume would be 4/3. Oh, sorry, it is cubed, not squared. Sorry, guys. I made a mistake here. It should be cubed. Okay. Let me do it again. So the formula says cubed. So 4.755, which is the radius, cubed times 3.14 times 4 divided by 3, which is 450.1, the volume of the basketball, inch cube. So this would be 4 over 3, 3.14 times the radius is 4.195 cubed. Don't forget it's cubed. 4.15 cubed times 3.14 times 4 divided by 3 is also 309.1 inch cubed. So the difference between the two will be the difference is 450.1 minus 309.1. Which is 141 inch cube. Oh, so that's the formula, Deborah. So if you see the previous, sorry, I didn't check the. So if you see the previous slide, this is the formula. Right? The formula says 4 over 3 times pi r cubed for speed. That's from the formula. Okay, good. So I have one application problem, and I want you to do this. So this is like an ice cream cone. If you buy an ice cream, you have the cone at the bottom, and at the top you'll have a half sphere or like semi sphere. So find the volume of this. Assume it is ice cream, but find this ice cream cone, the volume of the total ice cream and the ice cream. Okay, so we have to divide it into two. So we have this is volume one. Volume one is cone. Volume two is half. Find the volume, and I'll give you. I think 4 or 5 minutes is enough. 5 minutes, and that concludes our lesson. So I'll type the formula for volume one and volume two. So the total volume will be volume one plus volume two, where volume one is 1 over 3 times pi r squared times h, plus volume two is half a sphere, so it is half times 4 over 3 pi r cubed. So that's the area of the sphere, 4 over 3 pi r cubed. So use this formula to find the volume. Yeah, round it to the nearest tens. Yeah, round it. Use 5 plus the nearest tens. So give me volume 1. Give me volume 1. You already finished your start. That means this one. So 1 over 3 times 3.14 times the radius is 9 and each square times the height is 14 plus this is 1 over 2 times 4 over 3 and 3.14 times the radius is 9 here. Anyone for the first part? 1187.9. Oh, you got 87? Hmm. I get something a little bit off. Uh, so 1186.9. The same thing. What about the second part? 1526.8 exactly. So this is 1526.8. So add the two, you'll get the volume of the ice cream. So plus 2713. Okay, any questions? So that's the last example we have. So we have like 15 minutes. So use those 15 minutes to check assignments. Some of you point out the assignment 6.1 and 6.2 expired before time. So if that is the case, I'll open them for today and tomorrow, maybe until Thursday. Okay. If you miss them, so 6.1 or 6.2. Okay. Okay. Thank you, guys. We have a wonderful evening. So I'll see you guys on Thursday. So Unit 6 is now done. We will move to Unit 12, I think, the next unit. Okay. Bye bye. See you guys.